Welcome to Otten Math. In this lesson, we're going to talk about tangent angles and their relationship to minor arcs. This problem comes from chapter 10.6, problem number 24. We have a circle, and we're given that RHOM is a rhombus, that RH and RM are tangents to the circle. And what we're trying to do is we're trying to find the measure of arc HM. Well, we know that the sum of the measures of tangent angles and their minor arcs equal 180 degrees. So the first thing that we're going to do is we're going to identify the measure of arc HM as x. Well, since the measure of arc HM is x, I know that the measure of angle R is going to be 180 minus x. I also know that the measure of HOM, or angle O, is going to be half of the measure of the intercepted arc, which is x. So I can say the measure of angle O is 1/2 of x. Now, because this is a rhombus, I know that angle O and angle R are congruent. So I can say that 180 minus x is equal to 1/2 x. Or 180 is equal to 3/2 x. Or x is equal to 120 degrees, which is your answer. In the next problem, we're going to talk more again about angle-arc theorems. This one comes from problem number 27 in chapter 10.6. We're given that we have two circles, circle A and circle B, and they're both tangent at point R. We're also given that PT is a common external tangent, and that angle Q is 43 degrees. And what we want to find is we want to find the measure of angle S. Now that's also going to be the measure, or half of the measure, of arc TR. So let's mark up again what we can infer from what we're given. Well, we know that QP, or PQR, is 43 degrees. That means that arc PR is going to be 86 degrees. Now what I want to do is I want to draw some additional auxiliary lines. And the first one I'm going to draw is from A to P. And I know that this forms a right angle. The second one is going to be from A to B. And because A and B are tangent at point R, I can draw a straight line through R to B. Next line I'm going to draw is going to be from B parallel to PT. So this looks common or similar to the process of finding lengths with common internal tangents. And then finally I'm going to draw a line from T to B. So what I've done here is I've created another rectangle by design. Okay, now that I know that this length here is 86 degrees, I can also say that this angle here, angle A, or PAB, is 86 degrees as well, because it intercepts the same arc, PR, that angle PQA intercepts. So if this angle here is 86 and this angle is a right angle, then I'm left with angle ABC equaling 4 degrees. If angle ABC is 4 degrees and TBC is 90 degrees, because I have a central angle here that's 90 degrees, then I know that arc TR is going to be 90 plus 4 degrees. So arc TR is equal to 94 degrees. Well, I know that the intercepted arc, the inscribed angle is going to be half of the intercepted arc TR. So 1/2, let's say angle S is equal to 1/2 of arc TR, which means that angle S is going to be equal to 47 degrees. Finally, let's move on to the last problem. And this problem incorporates other theorems that we've learned in prior chapters. So we're given that AB is the diameter of circle P. We know that QR is equal to 6, so I'm going to mark that up here. And I know that AB, all of AB is equal to 13. I also know that QR is perpendicular to AB, and so I've marked that up here. Well, if AB is equal to 13, then I know that AP, which is the radius, or A radii, is going to be half of the diameter, or 6.5. So what I want to do is, first I want to identify PR as x. And then I want to identify RB as 6.5 minus x. Secondly, just for the sake of visualization, I'm going to draw a line from A to Q, auxiliary line from A to Q, and another one from Q to B. I know that the inscribed angle, an inscribed triangle, and an angle that cuts off a diameter in a circle is also going to be 90 degrees. Because we know that this arc, which you're just going to have to envision, which comes around the circle, is equal to 180 degrees. And I know that the inscribed angle is half of that measurement. So I know that angle AQB is going to be 90 degrees. So here I have two angles, one at AQB and the other at, actually three angles, at ARQ and QRB that are 90 degrees. And I can use the theorems that we've learned with altitude on hypotenuse to solve this problem. So I know that the altitude and the hypotenuse, the altitude here is equal, the altitude squared is equal to AR times RB. So I can say that 6 squared is equal to 6.5 plus x, which is AR, times 6.5 minus x. So we're going to take that to another screen and solve this problem. So I have 6 squared is equal to 6.5 plus x times 6.5 minus x. And I get 36 is equal to 42.25 minus x squared. If I do the math and I do my foiling method, I'll see that plus x times 6.5 minus x times 6.5 gives me 0. So I'm just left with the first values multiplied by each other, 42.25, and then the last two values minus x squared, and then I solve from here. So I have x squared is equal to 6.25. And x ends up being 2.5. So back to my original diagram. If I know that x is 2.5, I can find out what RB is, because RB is 6.5 minus x. So I have 6.5 minus 2.5, which equals 4. And that equals our